Alright, this video is going to be a quick introduction on Prim's algorithm for finding the minimum spanning tree of a graph. I've drawn this graph here already, and what Prim's algorithm requires us to do is to keep a small list of nodes that we have previously visited off to the side, so I'm just going to write that down here. And then we have to pick an arbitrary starting point. So let's just go ahead and start with A. And we have now visited A. What we have to do while we're at A is pick the least weighted edge to a different node. So from A there are only two nodes connected, B and C has less weight, so we are going to add that edge to our minimum spanning tree. And we visited A, and we have now also visited C. And now we have to pick the next least weighted edge connected to the network of nodes that we visited. So available as an option, we have B or D or E or H. B, E, and H all have the same weight. We can't pick D because it is a higher weight than the rest of them. But B, E, and H are all the same, so we can arbitrarily pick one. Let's just say we're going to move to H, and we'll add this edge to our minimum spanning tree. And say that we will have visited H and add it to our list of visited nodes. And now at this point, the only node that we haven't visited in the entire graph is F. So we pick the least weighted edge connected to the set that we have visited, and at this point it looks like it's going to be the edge from H to E, so we'll add that edge to our minimum spanning tree, and we will have visited E, and at this point we have visited enough nodes that we have connections to the rest of the nodes in the graph. So yet again, we have to pick the least weighted edge, and at this point that's going to be E to D. So let's add this one to our group, and we will have visited D. And back through again, least weighted edge, that's going to be the connection from D to B. And we have visited B. And next, lowest weighted edge to connect another node. The connection from D to F or E to F or H to G are all going to be the same. So let's pick this one. Doesn't matter which one you pick right there. There are multiple minimum spanning trees to a graph, usually. And now we only have one node left unconnected, and that is G, and H to G is weight of 2, E to G is weight of 3, and F to G is weight of 1. So clearly we're going to pick the edge F to G, color that in. We'll say we visited G, added to our list, and all of the edges that are still unconnected are going to be removed. And so what we have left is the minimum set of edge weights that connect all nodes in our graph.